Okay, so we are going to start group theory now. Hello everyone. It's a pure mathematics topic. It's actually abstract algebra, the pure mathematics concept, and we are going to learn group theory 1. There is group theory 2 also, the complete package of group theory, whatever you say. So, today's class is going to be the introduction and definition oriented class. In the next class, we will discuss about sets and anything else or many things. So today is the introductory class. So we will learn this chapter peacefully because this is a pure mathematics chapter. We will not hurry up to understand all the things. We will learn this chapter peacefully, thoroughly, and perfectly. So, what is a group? Let let us visualize in a real world. If we say that we have a class, let's say this is a class. This is a class of 30 students. Here in the class there are 30 students. So there are 30 students. Some wear red shirts. There are some people or students who wore red shirts. There are some students who wore blue shirts. And there are also some who wore green shirts. And there are also some who wore yellow shirts. So if we say that we are we have to group themselves by using their shirt color. So we would group these students and say we have grouped some students in the class who wore red shirts. So what have we done here? We have done we have actually imposed an operation. What's the operation? Operation is the shirt color. So there are many students. They can be they can belong to the set. Here the set is the class. Here let us name this set as C. This is a set of 30 students, or there are many students. I would not draw all them. So there are students, 30 students, or write it as set of 30 students. And when we say that this is a group, we say that this is a group whenever an operation is imposed. So we have grouped the students who wore red shirts. So we, whenever we impose an operation to a set, we call that set is a group. But is this thinking can be applied to mathematics also? Yes, it can be applied to mathematics, but the operation should follow some properties. We will discuss them. And whenever we talk about the operation, that operation is going to be a binary operation. So you would write the definition of a group, and you will understand what is going. Let us write the definition. What is a group? A group, G, comma, composition. This is actually the operation, composition. A group G is nothing but a non together with a binary composition satisfying the following four properties. Closure property, associative property, existence of identity, and the fourth one, last but not the least, is the inverse property. That is the existence of inverse. We will discuss all these properties carefully. So, a group is written as first bracket G, where G is the non-empty set, comma. Composition, this is the binary operation which is used between two operands. So a group G, comma, composition non-empty set together with a binary composition satisfying the following four properties. What are the properties? The properties are closure, associative, identity, and inverse. So let's discuss all these four properties carefully. Let us go to the next page. Closure property. What is a closure property? Let A comma be any two arbitrary elements belong to the group G. Then closure property says that A compose B would also belong to G for all A and B belong to G. This is the closure property. So let's take an example. Uh, our integer set Z with respect to addition is closed. That means take any two integer, let's say -1 and 5. If we impose the addition operation here, it would return +4, which belongs to the integer set. So the integer set with respect to addition is closed. We can check that. Now the second property is associative property. What is associativity? Let A, B, C be three arbitrary elements of the group G. Then A composition B composition C will be equal to A composition B composition C. That is, the change of parenthesis won't affect the actual value. This would occur for all A, B, C belonging to the group G. So this is the associative property. We can similarly check for the integer set under the addition operation. It would imply the associativity. The next is identity or existence of identity. What is an identity element? Identity element is an element by composing this to any element. Let any element be A would return the same element. So, in terms of mathematical language, we express it as there exists an identity element E belonging to G such that A compose E is equal to E composed A is equal to A for every A belonging to G. So we have to learn the last property, which is the inverse property or existence of inverse. Inverse is nothing but inverse of an element. So let A dashed be the inverse. The inverse of A. When we call A dashed the inverse of A, we call A dashed the inverse of A if and only if A dashed composition A is equal to A composition A dashed equal to the identity element. We write it where E is the identity element. So, for example, let's take an example to clear this matter. For example, in case we take the first example, that is the integers with respect to addition. So to find inverse of any element, we have to first know what is the identity element here. Here the identity element is 0. 0 is called the additive inverse here, additive identity here. Additive identity. So to find inverse of an element, element 2 belongs to Z, we just find some element A dash or A such that 2 composition A dash What is the composition here? Plus or addition. 2 plus a equals 0, which implies a equals minus 2. So the inverse of 2 is nothing but minus 2. We would generalize it that for any a belongs to integer set, the inverse of a is minus of a, and it would work only for the addition operation, not for the multiplication operation. That would occur some different cases. So what we have learned here, we have learned what is a group. Group is a non-empty set together with a binary composition satisfying the following four properties. What are the properties? Closure, associative, identity, and inverse. And we have discussed all the properties carefully. That is, for any two arbitrary elements A, comma B belongs to G, their composition would also belong to that same group. What is associativity? That is, change of parenthesis does not matter the original value. So A composed B composed C is equal to A composed B composed C, and this would have to be, and this have to be occurred for all A comma B comma C belongs to G. What is identity? Identity is such an element by composing which to any element would return that element. That is, A composed identity is same as E composed A is equal to A, and this would occur for every A belonging to G. And the last but not least property, the inverse property, A dash belonging to group G would be called the inverse of A if A dash compose A is equal to A composed A dash equal to identity. So we would call A dash to be the inverse of A. So I think this is enough for the first class as an introduction class. We would learn about sets, subgroups, center of groups, cyclic groups, and many more topics later. So for the first class, I think this is enough. So okay, let's end the class.